Right, this is a quick how-to on oxidation numbers. I'm not going to read you the 6 rules because you're perfectly capable of reading those to yourself. One thing that we do need to know is that the oxidation number is not always going to equal the charge. Sometimes it will, sometimes it won't. You just have to add it up to see. So on example A, we have HCl, which is hydrochloric acid. If we refer back to our rules, we'll look at rule number 5, and it says hydrogen always has a +1. So hydrogen is a +1, and we want the total number of oxidation numbers to equal 0. Chlorine would have to be a -1. That's it. That's all there is to it. On letter B, we have carbon tetrafluoride. We are going to start with the most electronegative element. So this is the element that is furthest right on the periodic table. So for letter B, fluorine would be our most electronegative. And according to rule number 2, the most electronegative element will have an oxidation number equal to its charge. So the charge for fluorine is a -1. Now, if you'll notice, we have a subscript of 4. So we have 4 fluorine. All of them have a -1 charge. So right now our total is -4. To make this equal to 0, then carbon has to be a +4. Let me rewrite this. -1 times 4. There we go. Now that equals 0. All right, on sample problem 3, phosphorus trichloride. Chlorine is further right on the periodic table, so it is more electronegative. Its charge is a -1. We have 3 of them, which gives us a total of -3. So to make -3 equal 0, we're going to add to it a +3. So the oxidation number for phosphorus is 3. The oxidation for chlorine is -1. Right, letter E, now we have 3 elements. We'll follow our same rules. Hydrogen, always a +1. Oxygen is always a -2. We have 3 of them. And this whole thing needs to equal 0. So with oxygen, we get a total of -6. Hydrogen is a +1, so right now our total is -5. So to make -5 equal 0, we need to add a +5. So hydrogen has an oxidation number of a +1. Nitrogen has an oxidation number of +5. And each oxygen has an oxidation number of -2. Right, letter F, potassium hydride. Neither one of these elements are really electronegative, so we'll start with rule number 5 that said hydrogen's always a +1. So if we want to equal to 0, that means potassium has to be a -1. So potassium has a -1 oxidation number. Hydrogen has a +1 oxidation number. Letter G, tetraphosphorus decaoxide. Oxygen is our more electronegative element, so it gets a -2 charge. We have 10 of them. We have 4 phosphorus atoms. So we need to figure out how to make phosphorus total our -20 from oxygen. So we need a +20. So that means phosphorus is going to have a +5 charge. Each oxygen has a -2. Each phosphorus has a +5. Letter I, dinitrogen pentaoxide. According to rule 4, oxygen's always a -2 charge. We have 5 of them. The whole thing needs to total 0. So our oxygen gives us a total of -10. Our nitrogen has to give us a total of positive 10. We have 2 of them, so that means each nitrogen is going to be positive 5. I'm sorry for the terrible handwriting. It's the smartboard, not me. So in letter I, each nitrogen has a positive 5 charge. Each oxygen has a negative 2 charge. And then lastly, we have J, germanium dichloride. None of these elements have specific oxidation numbers, so we go back to rule number 2, the more electronegative element. That would be chlorine, it's further right. Its charge is -1. And we have 2 of them. We want this whole thing to equal 0, so that means germanium has to be a positive 2. So germanium has a positive 2 oxidation number, and each chlorine has a -1 oxidation number. All right, and that should be everything. If you have further questions, if you still need more help on this, please see me sometime during class or after class.